Okay, class. The formulas we have been using for the exponentials are these ones. This is the natural exponential base. U is a function of x. So we have this composition. So the derivative of e to the u is the derivative of a compound function. So we have to put the derivative of the exponential, that is the exponential again, times the derivative of the u prime, or the derivative of the exponent. The integral is pretty much the same thing. So e to the integral of e to the u is e to the u plus c, correct? For the natural log, we have been using this ddx of ln u. This is 1 over u times u prime. And, well, what is the integral in this case? The integral is 1 over u du is ln absolute value of u plus c. This is what we have been using, the 4 formulas we used last week. Derivative of the exponential, derivative of the log, integral of the exponential, and not integral of the log. We are not integrating this. We are using this ln to find the one, the whole we had in our power rule. Remember, our power rule was u to the n du was u to the n plus 1 over n plus 1 plus c, but providing that the n was different than -1, correct? So that was the condition. So we had this gap here in our rule, but with the natural log, we fill the gap. So we have the integral of all the powers we can find, okay? So this is going to be what we are going to do today. We're going to find, the derivative of, right? We're going to have the derivative dx of a to the x, right? Where a is any number different than 1 and a positive number, correct? So any real number different than 1 and positive. So we can have, for instance, f of x equals 2 to the x, right? Okay. Then we can have, man, what is doing this? Okay. F of x equals 10 to the x, and so on. So any exponential function with base different than e. So the idea is, what is going to be this derivative? Well, it's going to be very simple. So this is going to be the trick. If e to the x, ln to the x are inverses, right? Then this is going to happen. E to the x, e to the ln x equals x, and ln of e to the x is equal x. So they are going to cancel, correct? So this is what we are going to use to find this derivative. So a to the x is going to be e to the ln of a to the x. So it's what is the exponential form we are going to use. So we're going to use this property. We're going to compound these ones. I'm not going to change the x, but now the x is going to be really a to the x. So this is equals this. And now I'm going to take the derivative. Derivative respect x of a to the x is going to be derivative respect x of this expression. But I'm going to do something. This expression, by the properties of the logs, is going to be e to the x ln of a. So I can move this exponent at the front of the log. Now, in this case, I'm going to have e to the ln ln a, right? Ln a. And I'm going to use the formula I know. This is going to be e to the x ln a times the derivative of x times ln a. ln a is a constant, so this is going to be simply, let me just move this a little bit ahead. So this is going to be simply e to the x ln a times ln a, because the derivative of x is 1, so I have this one. Now, what I'm going to do is simply, I'm going to return this expression to the original one. So this is going to be a to the x times ln a. So this is going to be the way we are going to get the derivative of an exponential function. So if we have, for instance, the function f of x equals 2 to the x, and I want f prime of x. So what is the derivative of this function? So it's going to be very simple. F prime of x is the derivative respect x of 2 to the x, correct? Now I'm going to use my formula, this one, right? Let me just take this out. This formula, right? So the only I have to do is write the ln of the base times 2 to the x. And that's my derivative. Not a big deal. If I want, for instance, f to the x equals 10 to the x, and I want f prime, so f prime of x is going to be, okay, derivative respect x of 10 to the x. So I want the derivative of the new exponential. Well, you only have to put is the ln of the base times 10 to the x. So it's very, very, very simple to get the derivative of any exponential function with base other than e. If, for instance, I get this strange function, pi to the x. Pi is a constant. So f prime of x is going to be ln pi to the x. So not a big deal. It's pretty simple to get the derivative of exponential functions with base other than the natural. Okay? No questions here? Pretty simple. Okay, let me see now what is going to happen with the log. So, what is going to be the derivative respect x of the log in base a of x? So, this means that I can have log in base 2 of x, log in base 10 of x, so any of the logs we work in pre-calculus, correct? So no problem. So what is going to be this derivative? Okay, so, well, I have to recall something. I know that dx of ln x is 1 over x, is what I know. So this is what I know. So what I'm going to do is the old expression to get the derivative or make the change of base. So what I'm going to use is this property. Log in base a of x is going to be ln x over ln a. This is the formula for the change of the base. If you have a log in base 10, you can change to the natural log in this way. So ln of x over ln of 10. So this is a formula that is coming from the algebra. So if we want ddx of the log in base a of x, this is going to be, okay, ddx of ln x over ln a. ln a is a constant, so I'm going to put this constant out. ln a times, and the derivative of the natural log is given here, so the only I have to do is put 1 over x. Okay? So it's going to be quite simple to get the log. It's the same formula, except that you have to put the natural log of the base in both formulas. In the log in the denominator, for the exponential in the numerator, correct? Let me just put again this one here. ddx of a to the x is ddx of e to the x ln a. So this is ln a times a to the x. So those are the two new formulas we're going to be using for differentiation. Okay, let me just put it right here. Admit Leonel. Okay. No questions? Everybody fine? Yeah. Okay. Remember this, please. The assignment we're going to be using today is right here in the Google Classroom. Where is the Google Classroom? Right here. Okay, you can see the screen. So I put this post yesterday in April the 5th. So for April the 6th, this session is going to be differentiation integration of logarithm and exponential functions with other bases than e. Okay, you didn't have problems with the meeting ID and the password. I see that. And these are those assignments. Here you can download the assignments. The assignments, right? Let me just share again this one. One is right here. So this is the first assignment, correct? The first assignment containing derivatives, right, of simple functions, correct? So, if you can see those formulas, well, we did already the first one. So it's right here. Stop share. Is right here is the first example I gave. The derivative of 2 to the x is the derivative, simply the same function times the ln of 2. And well, the only thing I have to do now is, let me see again, share screen. What is the derivative of the log in base 2 of x? This is, well, that is not going to be a big deal, right? So this is f of x equals log in base 2 of x. Let me just stop sharing this one. So if you want f prime of x, so the derivative of the log in base 2 of x, right? This is going to be simply, according with my formula, 1 over the natural log of the base 2 times 1 over x. So it's going to be very simple, right? Again, let me share the screen. These formulas are a little bit more complex, correct? So I have, for instance, f of x equals pi to the sine x. Okay, let me just stop the share. Here you have here the pi to the sine x. Well, remember the formula we have to use. For a composition of functions, the derivative respect x of a to the u, where the u is a function of x, is going to be simply a to the u again times ln a times u prime, correct? So what I have to do is just apply the formula to my f. So f prime of x is, well, it's the same exponential, so I'm going to put pi to the sine x times the log, the natural log of pi, ln pi, times the derivative of the sine. Here is u prime. Derivative of the sine is cosine x. And that is my derivative of this function. So remember, this is the formula I'm going to use. Formulas, don't forget, they are in our formula booklet. By the way, I don't find here close to me. Yep. I know where it is. It's right here. Well, I don't find my formula booklet to show you, but, well, you know where these formulas are at the back of our formula chart. Let me just look for it. No. Right. Yeah, let me just look for it. This file, this one, APCalculus, formula chart. Enter. Okay. Okay. Let me just share the screen again with you, right? I share the screen. So remember, this is the cover of our formula booklet, right? So here you have the formulas. Here is the one we have just right now, right here, yep, right there. And these are the ones we are going to use today. Well, not the cotangent, sorry. I don't know what is selecting this one, but it's these four right here. Okay, those are the ones we are going to be pretty much using today. Okay, well, another example. Another example is going to be simple. Let me just share screen right here. So the problem you see here is the log. Let me just put it right here. The log in base 10, y is the log in base 10 of x cubed plus x squared. So let me just go to my board. Here is the board. Y equals the log in base 10 of x cubed plus x squared. So it's very simple. Y prime, oops, y prime is going to be derivative respect x of log in base 10 x cubed plus x squared. This is, well, this is going to be simple. Reciprocal of the natural log of this base, 1 over ln 10. Reciprocal of the thing inside the log, 1 over x cubed plus x squared, times derivative of the expression inside the log, derivative of the cube, 3x squared, derivative of the square, 2x. That's my answer. Correct? Not a big deal. So remember, I'm going to write my formula again, a different color. Derivative respect x log in base a of u is 1 over ln a times 1 over u times u prime. So that's the formula we're using, correct? That's the formula we're using, so I just repeating my formula. Remember, the fluency in this class with the calculus relies on your knowledge of the formulas. If you know the formulas, you go softly. If you don't, you're going to be struggling a little bit with this class, okay? Because you have to be dependent on the formula chart. And remember, in integration, you need to recall these formulas in order to do the proper use substitution and solve the problems. Okay, more problems, more examples, right? So again, this one, so we have these ones right here, okay, these four, yep. So we're going to have y equals 2x minus 2, 5 to the x squared minus 2x plus 9. Okay, just this is now the function we have to solve, y prime. So what is y prime? Okay, well, this function multiplies this exponential, so I have, right, to use the derivative of a product. Let me just put this one a little bit to this, f g prime. This is f prime g plus g prime f, right? So we use this formula, or fg prime. We don't want to change the order. So we have to take the derivative of this times this, plus this times the derivative of this, correct? So let me just put y prime equals derivative of the first one. Derivative of this is 2 times the exponential not e 5 x squared minus 2x plus 9 plus the first function 2x minus 2 times the derivative of the exponential is, well, the derivative of the exponential is the exponential again, x squared minus 2x plus 9 times the natural log of the base. Now, the algebra you can do, if necessary, is, well, you have this repeated, so you can factor, so you can have parentheses 2 plus ln5 times 2x minus 2 parentheses 5 x squared minus 2x plus 9. Okay, this algebra is optional, so this expression expanded like this is correct, so you don't have really to worry about this one, but it's a good idea if you practice your algebra. Okay, so this is a common factor, so you take this and this expression with these two numbers in a parenthesis, multiply times the common factor, and then you get your algebraically correct answer. But the first one is also correct. Questions before I move to the next example? This is so easy that it's boring, I know. Okay, but well, you're going to have the practice today. Tomorrow I'm going to do integration. I don't want to go too fast today. Let me see. Yeah. Today I'm going to finish these examples, then you have your practice. If some of you are missing the previous homework, remember, it's in Google Classroom. It's the H50-02. So go solve. Even if you don't finish, submit something. Then you can see your present grades right now. If you have an 80, it's because you have not turned it in yet, the homework. Okay, so raise that grade to 100, please. Okay, next problem. The next problem is going to be y equals pi to the x times tangent x. Remember that these functions have only the purpose to make you practice the rules. Practical application of these functions, well, not really too much, but, well, this is for practice. Okay, I'm just going to put here the product rule, f prime g plus f g prime, correct? That's the product rule. I'm going to put here the derivative respect x of a to the u is a to the u times ln a. So those are the calculus, correct? So what I'm going to do is do this calculus, okay? So this is, all this is u. So, okay, I'm going to put y prime equals pi to the x tangent x. So I'm going to put this portion right here, is right here, times the ln of the base times ln pi times u prime is what the one I forgot here. Sorry, this is times u prime. Okay, so it's going to be x tangent x prime. So I have to take the derivative of this product using this formula. So this is going to be pi x tangent x times the ln of pi times, well, this product is going to be computed in this form. So derivative of the x is 1 times the tangent. So it's going to be tangent x plus the first function, so the x, times the derivative of the tangent. The derivative of the tangent is the secant square. So this long and scary thing is the derivative of this function. But remember, this looks scary, but it's not that difficult to get it, just using the calculus formulas. Okay, I'm going to give you a little bit you to copy down. Okay. Okay. Another example. Let me just take this one. Now is the log. So I have y equals the log in base 3 of sine x, right? Okay, what is the formula I'm going to be using? Again, derivative respect x of log in base a of u. So it's 1 over ln a times 1 over u times u prime. That's my formula, correct? That's the formula I have to use. Okay, y prime equals, following my formula. The base is 3, so I have to take the natural log of 3. 1 over ln 3 times. I need the reciprocal of the argument of the log. Okay, this is sine x, so it's 1 over sine x times the derivative of the sine. Oops, I don't know why I have this blurry, sorry. U prime, so is derivative of the sine cosine x. Okay, now some algebra. If you want to do some algebra, this is okay. 1 over ln 3, well, nothing to do, but the cosine over the sine is the cotangent. So you can put here cotangent x. That's my answer. So we don't have to worry too much. It's very simple knowing this formula to get these derivatives. You see, the algebra after, well, is optional. It's good you try because that is a review of certain concepts like the definitions of these functions, and you get your algebraically correct answer. This is also correct. Don't worry. Okay. 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 The last example. So we have y equals the log x minus 3 times 3 to the negative x squared. So I have this thing. So again, my formula to use, okay, the same formula, u prime, okay? Now, this is a product, so I have to, again, the product rule, a prime g minus f g prime, correct? And okay, y prime. Derivative of this product, because it's this log times this exponential, so I have to do derivative of the log, so derivative of this. And remember, if you don't see anything here, that is the base 10. So I have to put the derivative of this log in base 10 of x minus 3, so I have to use this formula. So it's 1 over ln 10 times 1 over x minus 3 times 1 times the second function plus log of x minus 3. And then I have to remember the derivative of this exponential as well is the exponential again, the natural log of the base times the derivative of the exponent, negative 2x. Okay? Now, you want to practice a little bit algebra, you can see that the only common thing you have here is 3 to the negative 3x. So you can put a big parenthesis with 1 over ln 10, 1x minus 3, plus, really minus with this negative 2, 2x 3 to the negative x squared times ln 3 parentheses 3 negative x squared. So you take this common factor and then you put the rest in parentheses and then you get your algebraically correct answer. Okay, everybody? Well, I guess this is good for today. Tomorrow we're going to do the second part with integration, okay? So I don't want to go too fast. So please, you have the practice, yeah, is right here. Let me show you. Is the one with the black highlighted name. So you can see here the practice. So if you try this front part, very simple, yeah. Then this is going to be application. We can go through this tomorrow, right? But today, I'm happy you learned this. It's very simple. No questions, Luisito? No questions? Isaiah?
No questions.
Jasmine?
No.
Yvonne?
No.
Jorgito?
I understood something for once today.
Okay. Luis Juarez, everything fine?
Yeah, everything fine.
Okay, very good. Okay, well, let me just stop the recording.